Hey everyone, so this is our sequence review for that quiz. If you missed a couple Fridays ago, we took our sequences quiz. I know some of you were gone for vacations, whatever it might be. This is the review that we basically went over that day in class before taking the quiz. And I just wanted to give you all a chance to see this and refresh your memory because I know it's been a little while. So first thing we want to do is just say the differences between our main two types of sequences. We have arithmetic, geometric, and then there's our other sequences. And we'll get to that other in just a minute. But first, let's start off with that arithmetic. Now, to know we have an arithmetic sequence, we can add or subtract the same number each time to get to the next term. So we're adding or subtracting for arithmetic, but for our geometric sequences, that is multiplying. So a big difference there. Now, it's better for you to think of geometric as multiplying because we use our formula that we're going to talk about here in just a second as a multiplicative number. We're multiplying something each time. Our equation is not set up for a dividing. We have to think of what number that would be as multiplying. So when you think of having divided by 2, we really want to take divides 2 and change that into multiplied by 1/2. So if you have something that's divided by 3 or divided by 5, really those are just the fractions of 1 over whatever number you said you were dividing by each time. Okay, so that's the differences between arithmetic and geometric. Let's talk about their actual formulas and what each thing means with these sequences. So our arithmetic formula is AN equals our common difference times the numbered term we're trying to find minus 1 plus A1. Now, remember we do n minus 1 because we said A1 stands for our first term. That's the first thing listed in our sequence. It's the first term that we have in our list of terms for an arithmetic sequence. And I already said that D stands for the common difference. It's the number I am adding or subtracting each time. N is the same for all of these. It's the numbered term we're trying to find. Numbered term. So we could be trying to find the 20th term. We could be trying to find the 50th term. For the most part, they're usually pretty small, though, for us to find for right now. And then we have AN. We have this AN up here. AN just means it's the number at that term. Or in other words, it's any term in our sequence. So if I'm trying to find n term, so say it's the 20th term, this would be A20. It's the 20th term of that sequence. For geometric, though, the equation's a little bit different because we're multiplying each time and not adding or subtracting with a common difference. We're multiplying by a set ratio. So we have AN, and that equals A1 times our ratio with an exponent of n minus 1. Now, the reason why we have exponent here and multiply here is multiplying by the number term we're trying to find tells me that I've added my common difference or subtracted my common difference this many times. Where I'm multiplying over here, in order to multiply the same number many times, I need to use an exponent for that. So that's the difference between the exponent and the multiplying. So now let's go through again. We said A1 is our first term. That doesn't change. That's always going to be the same thing. Our common difference, though, isn't our difference anymore. It's our ratio. And we call it a ratio because we're multiplying. Remember, geometric means that we are multiplying. N is going to be the same thing. It's still the numbered term. And AN is still any term. Now, again, both of these sequences have n minus 1 in them because we are counting our first term. Since I'm already counting one term, that means that I need to subtract one thing off of these terms. Now, let's do an example of each of these before we move on. So if I have the sequence 5, 7, 9, a couple of things I might ask you to do is to tell me the first term and the common difference. List the next 3 terms. Now, we already know that this is arithmetic. I've set it up that way so you know. But if I didn't know and I wanted to say, well, there are a couple of ways I could go from 5 to 7. I'm either adding 2 or I am multiplying by 7 over 5. Now, you all know me. I'm not going to give you some crazy fraction like that right off the bat. So let's just go again. If I know this is going to be plus 2 to go from 7 to 9, but to multiply, I would be going from 9 over 7. So we know that these two fractions are not the same. Clearly, the numbers are different, but we are adding the same number each time. So this has to be arithmetic. We're adding 2 both times. Now, if I know that this is arithmetic, I can say my common difference is 2, and I can say my A1 is 5. That's my first term and my difference. Now, if I wanted to find A of 15, I would take this equation up here and use what I've found to plug in for that. So we know that our common difference is 2, our D is 2, n minus 1, we're not changing that just yet, and then plus our first term, which is 5. Now, since this 15 is down here instead of n like it is up here, we know that our n has to be 15. So we can change that to be 2 times 15 minus 1 plus 5. Now, we can keep going here, and we would get 2 times 15 minus 1 gives me 14 plus 5. And 2 times 14 would be 28 plus 5, which gives me 33. So our 15th term in that sequence would be 33. Now, if we look back here at a geometric sequence, though, and we decide to start off with negative 24, and then 12, and then negative 6, there's a couple of things that we want to notice about this. First thing that we want to notice is that I go from a negative to a positive back to a negative. Now, that's a key sign for you that this is only going to be a geometric sequence. It cannot be arithmetic. There's no way that I can add the same number each time and go from negative to positive back to negative again. So since we know that, we want to first figure out if I go from 24 to 12 in terms of multiplying. Well, we said that when I divide by 2, I know 24 divided by 2 would give me 12. That's the same as multiplying by 1/2. But we have to be careful, we're changing the sign. Now, it works the same way if I'm dividing or multiplying. This just simply becomes negative 1/2 or dividing by negative 2. We can do the same thing from 12 to negative 6. We can either think of it as dividing by negative 2 or multiplying by a negative 1/2. That's how we get the sign to change, is we're multiplying by a negative. So now if I were to ask you to write the next 3 terms for this one, we would say that the next term, negative 6 times a negative 1/2, would give me a positive 3. The next term after that would be 3 times a negative 1/2, which is negative 3/2. And the next term after that would be negative 3 over 2 times a negative 1/2. Well, let's do that over here just so we can all stay on the same page a little bit better. Negative 3 times a negative 1/2. When I multiply fractions, we multiply the tops together and the bottoms together. If I multiply negative 3 times a negative 1, that just becomes a positive 3. And 2 times 2 gives me 4. So this is 3 over 4. So that would be the next 3 terms in that sequence. But now let's say that we want to say what the common ratio is and use our formula to find whatever term it is we want. So now if we are filling in for our common ratio, we would say R equals, well, we already said we're multiplying by a negative 1/2. And our first term is still the same thing. It's whatever thing comes first. A1 is negative 24. But now we want to use this equation up here. So we would have AN equals negative 24 times a negative 1/2 to the n minus 1. But now say I want to find a specific term. I want to find A8. I want to find A8. Now, in order to do that, I would need to plug in 8 for n up here. Negative 24 times a negative 1/2 to the 8 minus 1. Now, one thing we could do is we can either use a calculator app or we can use this handy-dandy one that I told you to get the other day in class. It's a nice little TI calculator. So you're able to still use graphing capabilities, all the good stuff. It's a little bit of a higher powered graphing calculator though. So now this next step, I'm going to put this over here. We would want to next subtract our exponents. So we would have A8 equals negative 24 times negative 1/2 to the 8 minus 1, which would give me 7. Now, some of you are able to do this on different ways. I would type this in just as it appears on our paper here. 1 divided by 2. And then to get an exponent, you're just going to use this caret button, this little upshift key here. And we said our exponent is 7. So that's the same thing as what we have written out here on our paper. And when I put that in, we get a crazy fraction, which we kind of already knew was going to happen, right? We were getting crazier and crazier fractions as we kept going down. But now if we wanted to write this as a fraction, we could by using math and fraction, which would be 3/16. Just to keep that fraction going, we would want to do that. Now, I said that this is not the only type of equations or sequences that we have. Sometimes we have sequences that don't have a specific formula or specific equation. There's 3 different kinds that I had brought up. And one of them is a very special type of sequence. We called it the Fibonacci sequence. You might remember talking about Miles the bunny and hopping up the stairs. The Fibonacci sequence is a special one. Normally, it starts off with 0 and 1, and you get the next terms in the sequence by adding the 2 terms before it together. So 0 plus 1 would give me 1. 1 plus 1 would give me 2. 1 and 2 would give me 3. 2 and 3 would give me 5, and so on and so forth. So if I asked you, maybe I started off at 1, 2, 3, 5, and I give you those first few terms, you would know that the next 3 terms should be 8, 13, and 21. Now, the Fibonacci is a special sequence because it doesn't really follow either our adding or subtracting and multiplying like we did for arithmetic and geometric. It has a pattern, but it's not necessarily the same number each time, but it's the same method every time. There's a couple of other types of other sequences. Sometimes we can use the alphabet. Alphabet. So if I were to give you the sequence B, D, F, well, we said that sometimes we can write out the letters themselves. Sometimes we can skip so many letters. This one is specifically skipping every other letter. We would have A, C, E. So if we skip G from F, the next one would be H. We would skip I and go to J. We would skip K and go to L. So those would be the next ones. And the final other that we talked about was using arrows. So sometimes we'll have left, down, right, up, and they would keep going around and around. And so we would have left, down, right, up. You could keep going around in that same counterclockwise pattern to list your arrows. So with that being said, these are all of our different types of sequences. If you have any other questions about sequences before you take that quiz, please let me know.